Following on from the previous video, I was struggling to explain to you guys why we can just throw away x to the power of 3 and x to the power of 4. We got to this stage here. Hang on. We got to this stage here. Okay, I then asked you to multiply this out, multiply this, and so on here, and then that led us to this. And then when you simplify it, you can you would get to this. You would get to this stage here. Okay, and then we got to this stage in the previous video, and I said that well, at the moment you can visualize it as one block, and then you've got another block here, you've got another block here, you've got to you add this block and then add this block. The thing is, we want I was struggling to explain why we can throw away these two terms here. The reason why we can throw away these two terms is because when x is small, when x is, let's say, when x is near 0, so let's say 0.00003, say, this is pretty close to 0 here. You see, this thing, when you square it, it would be a quite small number. But and then when you come to do this here, if you cube this, whatever the cube will be, it would be negligible in comparison to x squared. So this number here to the power 3, when you have a really small number and then you cube it, it will be so small in comparison to x squared, and this here will be even smaller than x squared. The point here is that when these two terms will be nothing in comparison to these two blocks here, or these three blocks here. These two terms will be nothing. So we would throw away these two terms here, or even if you have something to the power of, let's say 7, let's say 38 over 342, you can even throw away this term as well, because the thing is, anything, if you have powers higher than 2, the blocks, these blocks will be so small in comparison to these three blocks here. So don't forget, we are already, this here is already an approximation. So if you add some even tinier amounts to this thing, it makes no difference. So we try and keep it simple. So rather than keeping the whole thing here, let's just keep it simple and just concentrate on these three terms here. Okay. Yes, we will lose accuracy. We will lose some sort of accuracy. But the thing is, we will sacrifice accuracy for something a lot simpler. So keeping just these three here, it will be a lot simpler than trying to keep these. And these, they're not going to make much of a difference in comparison to these three here. Okay. So anything higher, we can drop these. Throw these away and keep it nice and simple here. Okay, so that will then give you so we can say that this complicated thing here will approximate to this thing here. So if you get your graph plotter and plot the plot this graph, and then later plot this graph here, it will give you this graph here. It will give you this. So when x is near 0, you can see it is a good approximation. Hang on. It is a good approximation here. Okay, so hang on. So going back, when you are here, when you're at this stage here, don't bother multiplying out the whole lot here. So when you are here, hang on, when you are here, I'm going to take it down to down here. Hang on. When you are here, and let me just scroll down. So when you are there, when you are here. Okay, when you come to multiply it out, just get this times this, that will give you this. This times this, that will give you this. This times this here, that will give you this. Okay, bear with me. And then this times this, that's okay, so that will give you this. This times this here, that's okay, that will give you this. This times this here, don't bother doing this because you've got x. And then you multiply with x squared here. That will give you x to the power 3. So you don't really care about x to the power 3. You're going to drop it. So when you come to do this here, just do this times this times this, and then you know that you're going to get x to the power 3. So don't waste your time doing x to the power 3. Okay, and then when you come to do this times this here, that's this thing here, and then this times this, that's going to give you x to the power 3. So don't bother doing it. And then this times this here, that will give you x to the power 4. So don't bother doing it. So when you come to do this here, all you have to do is just up to here and then simplify it. Okay, rather than what we did all the way up here. Hang on. So before we were here. Okay, and then we did this whole thing here. The reason why I did this whole thing here is just to illustrate to you that you would get something like this, and then you can just drop these two terms here. Okay, so when you come to do this, yeah, so when you come to multiply this out, only care about x squared, x, and the single number. Don't worry about x to the power 3, x to the power 4. Anything higher you can pretty much throw away. Okay.